Good morning. This lecture is on porosity in dental casting. For fabrication of fixed dental processes or removable processes or metallic denture bases, we need to make a wax person which will be converted into final processes by means of casting. There are so many reasons for failure of casting from conversion of wax pattern to processes. The one among this is porosity. What are the reasons for porosity? This may be due to improper melting temperature of the alloy, which will produce as an empty space in the material. This porosity may be an internal porosity or an external porosity. As a result of this porosity, the processes may be weakened, or you can see discolored processes. Sometimes it may lead to surface roughness, which leads to accumulation of plaque. There are so many porosities, and let's see the causes and its management. First one is localized shrinkage porosity. This may be due to premature termination of flow of metal during solidification of the alloy during casting. This occurs near the junction of sprue and the casting. This is may occur at the bulkiest portion of the casting. How to prevent this porosity? We need to attach a large sprue equal to the sprue thickness very close to the wax pattern, as far like 1 millimeter from the wax pattern. So this will prevent the solidification shrinkage. As the metal solidifies from the pattern, it will make direct contact with the reservoir so that we can avoid this localized shrinkage porosity. Next one is back pressure porosity. This back pressure porosity can be seen on the fitting surface of the wax pattern near the sprue attachment. Mainly it is occluso-axial or incisor-axial line angle area. If the wax pattern is not well rounded, if there is any sharp area, that will lead to back pressure porosity. The other reasons for back pressure porosity is if the sprue is attached right angle to the wax pattern, or turbulent flow of metal, or improper pattern of pattern position, or long and narrow sprue leads to back pressure porosity. The other reasons are if the investment is very dense and the wax pattern is very large, and inadequate casting and mold temperature, or clogging of mold with residual carbon. How to prevent it? Proper burnout temperature, an adequate time for casting and melting of the alloy, and high casting pressure, proper liquid and powder ratio during investing, and the thickness of the investment between pattern and the end of the casting should not be greater than 6 millimeters. The next one is suckback porosity. You can very well appreciate the porosity near the cuspal pattern. You can see the suckback porosity again at the junction of the wax pattern and the sprue attachment. If the sprue is attached 90-degree, or if the sprue is too thin, leads to suckback porosity. This porosity is otherwise called hotspot porosity. How to prevent it? This suckback porosity can be prevented by attaching the pattern and the sprue with 45-degree angle. We are not supposed to attach this wax pattern in the functional area. We need to attach the sprue at the non-functional cusp area, and the flow of metal should be continuous. Next one is marginal discrepancy. This marginal discrepancy is due to distortion of the wax pattern while transferring from the die for investing procedure, or uneven expansion of the investment material in the casting ring. Next one is microporosity. You can see irregular shape voids inside the metal. We cannot see with the visible eyes. It will be seen only under microscope. So this is due to solidification shrinkage of the fine grains in the casting alloy. Next one is subsurface porosity. These porosities will be seen below the surface of the casting. This is due to molten metal which come in contact with a low temperature in the mold, which will form a layer of porosity with the mold wall, which solidifies suddenly. When the inner layer shrinks, the outer covering of the solid metal cannot be dragged along with it. For further details related to casting porosity, you can refer the following textbook. Thank you.